Thank you so much for joining us. We are going to be looking at the application, modeling, and problem solving of networks. So just to remind you, a network below shows the road layout in a new housing estate. The vertices represent the road intersections and the weighted edges represent roads and their lengths. So to start off, it says cars can enter this estate through gates located at either A or J. So we are looking at entering A and J. So we are going to be entering the estate at gate A and leaving at J. And we need to look at the shortest distance. So when we think about shortest distance, we're trying to look at the less distance. So which means when I look at both A and J, I look at what is the shortest distance on what one of those to travel, and that's 500 meters and 300 meters. Likewise, if I look at L to K and I to L and K to F, that is a lot bigger than going directly to H, G, and F. So this is where we can quickly see here our shortest route. And now I have identified the shortest distance is going to be from A to F to G to H to I to J. If I would like to know the shortest distance, I'll be going 500 plus 500 plus 500 plus 800 plus 300, and this equals 2,600, so 2,600 meters. Let's look at the next question. It says the post office is located at G, so I'm just going to put a mark on G. The postman must travel along each road in the estate at least once. Because we're talking about the edges, the amount of edges, we are talking about the Eulerian trail or the Eulerian circuit. Now, first thing I want you to think about, a circuit. That means it's going, we are going to have the same starting and ending point. For that to happen, we need to have all even degrees. If we look at the Eulerian trail, we are still going over every single X once, but we can only have, and we must have, 2 odd degrees. If we have any more, we can't. And in this case here, we do have 2 that are odd. We have our G, which we've got 3 degrees, and we've got our H, which is 3 degrees. So when we look at I, it states, can the postman start and finish his delivery round at intersection G without travelling along the same road more than once? The answer is no, and that is purely because there is 2 odd degrees. But the II states, can the postman start his delivery round at the intersection G and finish at some other intersection in this network? And he can, because we are going to start at G, go to F to B, B to A to F, F to K, K to L, L to I to J, J to E to D, D to I to H, H to C, C to D, D back to C, C to B, B to G, and we've got G to H. So we can go on every single X, but we will not land back onto the same, but we will land on H. Part C. Broadband is to be provided to the estate by connecting cables from the exchange located at the intersection L to nodes located at each of the intersections. What is the shortest length of cable needed to complete this task? So we know we need to get to every single vertex, but we want the minimum distance. So in this case here, we know we will put a mark at L. Now, when we are doing this, we need to be thinking about the shortest distance. So I know to get to K, it's easy to go from F than it is to go from L because it's the shortest distance. So we always look at the shortest distance, and that will help us out. Okay, so now from I know I'll go to J because that's 300 meters. Same with D, it's a lot easier from 500 meters rather than 800. And then I can go to E for 300 meters. Now we only want to use one of these 800 meters, not both. Now everything else is going from 500 meters, so it makes it a lot easier now. C is a lot easier to do from 500 meters than it was 800. Likewise with B and G. And now F to A. So here we go. We now have worked it out. Now we just need to calculate it. So we've got A to F is 500 plus the 700 from F to K plus the 500 from F to G. We've got G to B, which is 500, G to H, which is 500, H to C, which is 500, H to I, which is 800, I to D, which is 500, D to E, which is 300, I to J, 300, and I to L, which is 500. And this provides us the shortest amount of cable of 5,600 meters. And there you have it.